Dear students, today I will lesson about sets. Set of counting number to start from 1, 2, 3 and so on. And the set of natural number n, which refer for the 0 and all the positive number. Start from 0, 1, 2, 3, 4 and all the positive. Set of integers z, and it's divided into three parts: positive and 0 and negative numbers. And all those sets consist of whole numbers only. The set of rational number Q, it accepts all the number positive, negative, zero, fraction, which can be expressed in a form of A over B. So the rational number Q can put all the number in a form of A over B, but there is only one condition: when B is not equal to 0. Let's see this exercise. Put belong, doesn't belong, subset or not a subset. Any decimal belong to Q, and also any negative fraction belong to Q. Whole numbers belong to Q. But in that case, the 8 minus 8 equals 0, and we said that this is the only case that the Q doesn't accept, so this doesn't belong to Q. 15 over 5, which is equal to 3, belong also to Q. 2 minus 2 as 0 in the numerator also can be belong into Q. Quarter and set of rational number belong. This is a set and set, so the relation here will be negative 3 over 5. This already in the Q, so this is subset to Q. Negative 4, subset to Q. 5 over 5, 5 minus 5 over 8 in a set, that also subset to Q. 4 over 6 minus 6 in a set, that element is not already in Q. So this set doesn't subset to Q. The second part is going to give me a very important note, which is 0 over any number equals to 0. But any number over 0 is meaningless. This has no meaning in Q. Complete. If 3 over 8 is a rational number, then A is equal to, or A is not equal to, the A cannot be equal to 0. The next one, when I tell you about belong to Q or doesn't belong to Q, I have to look down. In this case, 5 plus x over 1 plus x, I will look down. What is the relation, or what is the number? When I put it here as x, it will give me 0. The opposite here, it's 1 as a positive, so when I put x with a negative 1, that will be doesn't belong to Q. When he tell me belong to Q, or is a rational number, or is not a rational number, I look down. In number C, x plus 5, so the opposite of plus 5 is minus 5. Okay, here doesn't belong to Q, also I will look down. When I put the x with 4, it will be doesn't belong to Q. In that example, 2 plus x is not a rational number, and the relation is multiplication. When the relation is multiplication, I go and make the x equal 0. 5 plus x over 3x, the same example, is a rational number when x is not equal to 0. Not equal to 0. Exercise 2. Find each of the following. If the fraction is equal to 0, I look up, and when I put the x with a value of negative 2, this numerator is going to give me 0. يبقى when it's equal to 0, I will look up. هنا 2 plus x, يبقى x equal to negative 2. The same here. Equal to 0, يبقى look up. يبقى the x is equal 4. Equal to 0, I will look up. The x is equal to 2. Exercise 4. Change into a rational number. Change into a rational number means that I have to put it in a form of A over B in the simplest form. When it's decimal, I'm going to make it 0.8, so it's 8 over 10. In the simplest form, 4 over 5. And that come easily using calculator. 85%, the percentage sign means that I have to make it divided 100. So using calculator, you are going to write 85 divided 100, and in its simplest form, 17 over 20. Any whole number can be changed in a form of a rational by using the denominator 1. 0.75 also using the calculator will be 75 over 100, and its simplest form 3 over 4. 0 can be expressed by 0 over any number, 1 or any number you changed. Negative 2 and 2/3 write as a mixed number, and I have to change it like times plus 3 times 2 equal, or 3 times negative 2, negative 6, and the negative will keep it, 6 plus 2 equals 8, and that comes easily using calculator. The infinite decimal. When I write those decimals on the calculator, 2 over 3, you are going to find 0.666 to infinite 6, and the last one is 7. So to express this in a decimal, it's called an infinite decimal or recurring decimal. I am going to write 0.6 dot. This dot refers for the number which is repeating. 1 over 3 is the same. I'm going to find it 0.3, lots of 3, so I'm going to write it 0.3 dot. The mixed number, the same, but in that case, I'm going to find the 1.6363. So I'm going to just write 1 point and dot above the 6 and dot above the 3. Also here in 2 and 1 over 15, 2.0 and the 6 is repeating, so the dot above the 6 only. What about if I want to put it back in a form of rational number? Any infinite decimal, I can write it the same number over 9. So this is 3 over 9. And in its simplest form, 1 over 3. The same here. 0.7 dot, it will be 7 over 9. And this is the simplest form. If I cut 2 dots, I'm going to write the 12 above 99. And its simplest form, 4 over 33. Here also 2 dots, يبقى 45 over 99, and its simplest form 5 over 11. This complete in each one he wants the case. 0.1 dot 5 dot equal 15 over 99, and 5 over 33 is the simplest form. If I want to make this into a percentage, I'm going to multiply the fraction by 100, and this is 15%, so I'm going to make 15 divided 100, which is 0.15 as a decimal. Comparing between fractions. Any negative number is less than the 0, and the whole decimal, the whole negative number, كل ما نكبر في الفاليو بتاعة الديسيمال يعني negative 5 is less than negative 4.5. The absolute value is going to give me 3 over 2. If I want to compare between half, I'm going to make crisscross. 2 times 3, 6, so this side is 6, and 2 times 1, 2, so in that case the 6 is more than 2. 0.6 dot means that it's 6 over 9, and in its simplest form it's going to be also 2 over 3. Write 3 rational numbers equals to this fraction. To get an equal rational number, I can multiply up and down by the same number. So 2 over 3 up and down times 2, which is equal 4 over 6. And 2 over 3, if I multiply up and down times 5, it will be 10 over 15. And 2 over 3, if I multiply up and down by 10, equal 20 over 30. يبقى you have to choose any equal number to multiply it up and down. Write 3 rational numbers between 3 over 4 and 3 over 2, such that one of them is an integer. To get the equal rational number between, I have first to make them common denominator. Here, 4 times 2 equals 8 as a denominator, then crisscross. 2 times 3, 6, and 4 times 3, 12. Can I write any numbers between 6 and 12? Yes. 7 over 8, 8 over 8, 9 over 8, till 10 over 8, 11 over 8. 8 over 8, which is equal 1, is the integer. Write 3 rational numbers between 2 over 5 and 3 over 5. When I got the 2 rational numbers after each other, I have to multiply by 10 for all the terms. 10 times 2, 20, 10 times 5, 50, 10 times 3, 30, 10 times 5, 50. Now I can write, starting from 21 till 29, any rational number that I want.